Okay, hi everyone. I got a question about the effect of external pressure of a NIRS device on your values, so on your muscle oxygenation values. So if you have a device and how much pressure you're putting on the device onto the muscle when you're mounting it, how that's going to affect um, your values. And that's a good question because it does. And there's a paper that actually with the Moxie compares the Moxie and the Portamon, and by Chris Cooper. I'll put some graphs up here, and you see that external pressure does affect your measurement. So this is something to be careful about. So when you are using your Moxie, it's important about placing the Moxie in the same spot. It's also important about applying the same pressure. So if you're just softly kind of putting it on and taping it in place, and the next time you're like forcefully pushing it on and really, then that's going to affect your values. So you need to be aware of that. You need to try to apply the same amount of pressure. But what I'm going to quickly do, we're going to go through this. I'm going to put my Moxie on really softly, and we're going to show some data, and then I'm going to push on really hard and show some data so we get an idea of how this actually changes. So we're gonna try that here. So I'm gonna pop my Moxie on. I have it on a real light right now. I'm not really pushing on. I'm making sure that the light shield is nicely guarding from my light. Yeah, and we're just going to kind of let this roll for a little bit and kind of average out here and see what I get. And now I'm going to you get kind of this 56% value. I think that's enough for now. And I'm going to push on this hard. This is going to be harder than I would normally ever mount this device. So I'm pushing on this pretty hard, and we're going to see what happens. So we see there's some change going on here for sure. Again, some variation. So this pressure is doing something to my measurement. Let's see what happens here. It's actually balancing out again. Let's stop this. Taking the pressure away again. Just kind of goes up a little bit. So the pressure has caused something to change. Now I'm going to push down again. Let go again. All right, let's kind of take a look at that, what that looks like over the entire measurement. You get this kind of wavy form thing going on every time I kind of release pressure and add pressure, that it does affect your SmO2 value. So you can have some effect going on. And this is a special case as well here, because I'm actually kind of pumping, I'm pressuring in and out and in and out. So that normally wouldn't happen. The point being that the pressure that you apply to your NIRS device is going to have an effect on the value, and it'll have an acute effect if you're getting kind of a pressure release of pressure, pressure release of pressure. This is important to remember minimally, also for like You have compression gear on, and you're going to get some variation in your NIRS signal because of the way that the compression gear is acting against the contraction of your muscle. So you're getting pressure changes. That's going to have an effect. So some of the change in value net is going to be affected by those pressure changes. That's going to add to some variability in your measurement. So that's important to know. It's always hard to gauge how much of this is a bunch of this is going to be kind of physical properties, in that you are changing tissue thickness by putting pressure on. You're changing the shape of the tissue, the shape of the muscle by putting pressure on it. So that's going to affect the measurement of the device based on the light scattering. But some of it is like also physiologically, that the pressure that you're applying is going to have an effect on how blood flows through that part of the muscle, on the effect of putting pressure on your blood vessels are going to have an effect. So to differentiate between those two is hard, how much it contributes to which side contributes how much. But there is an effect which is to be you need to be aware of. Now, I'm gonna take this data that I gathered and put this chart up here, and what you see is that you get an average. So you get you have the flat lines, the average line over the entire measurement. And we get this confidence interval zone. So this kind of grays, this highlighted zone tells us what is like our minimal detectable change. So anything within this range is the trending information is something, but the value is really hard to discern how impactful it is. If it's inside this range, it's really not that impactful. And what we really do see is that you kind of stay within this minimal detectable change, regardless if I had this high pressure point or this low, which is good because it gives us confidence that you need to really mess up the amount of pressure that you're applying to the device to then be worried that it's going to have a big impact on your measurement. So any kind of normal placement where you take a little bit of consideration about the amount of pressure the device is having applied to it on the measurement site, you should be completely fine using the device to measure for repeatable occasions. It should work perfectly fine, but it is something to consider, as Cooper and colleagues point out in their paper. So that was a good question to discuss from a kind of an application point of view. I hope that helps and gets people to think more about variations in their NIRS signal. Okay, thank you very much. Bye.